we're going to talk about the max flow algorithm, which is it's an algorithm which defines the maximum amount of flow, or the maximum amount of traffic we can push through a directed weighted graph from some source to some sink. So if you want, that's a very abstract definition. If you want to have a more tangible example, let's look at, let's say you have the Atlanta airport, and you have the Los Angeles airport. Let's say that the Atlanta airport wants to send as much traffic as it can to Los Angeles. Okay? So let's say it has a direct route which it can send, let's say based on FAA regulations, it can only have 30 planes flying in that specific distance. So for safety reasons, they don't interfere with each other. They can only fit 30 planes within that distance. Okay? And let's say maybe they want to send some planes to Houston. So let's say they can only fit 8 planes between Atlanta and Houston because of the FAA regulations. But they can fit 15 planes from Houston to LA. And it'd be Boulder, Colorado. I want to fly through Boulder. So Atlanta can fit 18 planes between Atlanta and Colorado. I'll say there's only 6 planes. Okay? But let's say maybe you want to allow, send some planes to Colorado and then send some planes down to Houston, so they can take an indirect route to LA. And let's say we can fit another 7 planes in the air doing that. So given these routes that we can take, and given these constraints of the maximum number of planes in the air, we want to find how should I send planes through the air such that I get the maximum number from Atlanta to Los Angeles. And you can imagine that this is a fairly simple example, but it can expand and get much more complicated. So it's not as easy as just looking at it and saying, oh, well, no problem. So we want to come up with some algorithm to do that. So let's look at some naive approach. So let's say I have this source and this sink. So I want to get it from S to T. I want to use as many as I can. Let's choose some random path. So I'm going to choose, let's be greedy and choose 20. I'll choose the largest edge every time. So 20, 30, and 20. Okay. The minimum is 20, so I can't pass any more than 20 across that path. So I can only fit 20 here. I could fit 30, but I don't have 30 to send. Even if I did get 30 here, I can't send 30 along this edge. So I can only send 20. So I have 20 so far. Right? So this edge, I have 20 planes in the air here, so I have 0 planes left. I can put here. I can't send 30, but I already sent 20, so I have 10 capacity left. And then here, send 20, so now I have 0 capacity left. So what we'll do is, to make it easier to see, I'm going to erase all the 0 edges. So both of those edges have 0 capacity left. Now, if we look at our graph, I want to get from S to T. The only way to get out of S is to go to A. Now, from A, I actually can't leave. So we see that this is the maximum, with this path, this is the maximum amount of planes I can send or maximum amount of flow I can get from S to T. So let's choose different paths. Let's say I want to go SA to T. Okay? So the mid distance, I can send 10, I can send 20, but I only have 10 sends up. That gives me 10 weight. So this is that capacity. I send 10, so that's 0. And I send 10 here, so I have 10 left to send. So I erase my 0 edges. And now let's choose this path. So I can send 20, but I can only send 10 on the second edge. So 10 is the minimum. So there's 0 left capacity left here, and there's 10 capacity left here. So erase the 0 edge. So that was 10 more that I sent. Now I can send 10 down this path, 30 up, and 10 back down again. So the min is 10, so I can send 10 here, 10 there, and 10 there. So you can see, if I erase this, if I erase only 0 edges, now there's no possible way to get outside of S, so I've used all possible paths for the combination of paths that I chose, and this ends up being 30. So, since these were identical to start, we see that actually is very important the order that you choose paths, or you have to have some intelligent algorithm or way of choosing the smartest paths. So we're going to present that algorithm next time.